equation of tangent to parabola. So if equation of parabola is y square is equal to 4ax. Now tangents we can find in different formats for different purposes. I can find at a point x1, y1. I can find equation of tangent which is passing through a point, that means from a point outside the parabola how many tangents can be drawn, what must be their equations. And next we can find equation of tangent in slope form. I can find equation of tangent in parametric form. So all these things we will see under this heading. First, tangent at a point. First is a tangent at a point P x1 y1 at a point. That means here the point lies on the curve. Whatever is the curve, point lies on the curve. So equation of tangent at this point. This point is P whose coordinates are x1 comma y1. That means I can say that this point must satisfy the equation of the curve. So y1 square must be equal to 4a x1 because this point must satisfy the equation of the curve. Now, how to find equation of any line? Point is known, the line is passing through this point. I must know slope of this line. And slope of this line is tangent. So slope of tangent is given by derivative of the curve dy dx at that point. So I will differentiate this parabola with respect to x, differentiating this. So differentiation of y square is differentiating with respect to x. Derivative of y square is 2y and derivative of y is dy dx by chain rule is equal to 4a. Derivative of x is 1. So from here we will get dy by dx is equal to 2 will cancel. So 2a upon y. And when I say that at this point, so at this point P, I will replace this with the coordinate of this. So at point P, that means this is y1. So this is nothing but slope of the line M. So now I can calculate equation of the tangent. So y minus x1, y1 is the point. y1 is equal to 2a upon y1 into x minus x1. Cross multiply. So y1 minus y1 square is equal to 2ax minus 2a(x1). And now we can use this set result. y1 square is equal to 4ax1. So this I can write here. So next I can write y1 is equal to 2ax minus this y1. y1 is how much? 4ax1. y1 square is equal to 4ax1. So 4ax1 will go this side. Minus 2x1 cancel. So what will be left? Plus 2ax1. So y1 is equal to 2ax plus x1. This is the equation of tangent. A shortcut method I have given in the chapter of circles. I can directly write tangent at a point. Tangent at a point is given by t is equal to 0. What was the method if you have remembered? Replace x square with x1, y square with y1 if they are present. 2gx or 2fx, whatever is there. 2gx with half of the coefficient of x, g x plus x1, 2fy with f, half of the coefficient of y, y plus y1, 2hxy with half of the coefficient of xy, h, x, y1 plus y, x1, and c remains c. There is no change in the c. This condition you can always use for second degree equations for finding equation of tangent at a point t. Here only important condition is point must lie on the curve, otherwise I cannot use this equation. So in this case, equation of tangent will be y square. Suppose my curve is y square is equal to 4ax. So replace y square with y1 minus. So this you can write y square minus 4ax. This is the s is equal to 0. Minus half of the coefficient minus 2a. Replace x with x plus x1. So in shortcut method is equal to 0. This will give me equation of tangent. This is the same equation which I have derived there. So this is one form equation of tangent when point lies on the curve. From this I can derive parametric form. Parametric form. That means at point P, 80 square comma 280. So replace x1 with this, y1 with this. So I will get y 280 minus 2a into x plus 80 squared. 2a will cancel out. So ty is equal to x plus 80 square. Ty is equal to x plus 80 square. This will be my equation of tangent at point T. Method is same. First we will find dy dx. Then we will find equation of line at a point by using y minus y1 is equal to m into x minus x1. And this point lies on the curve. So y1 square is equal to 4ax1. Then I will get the equation of tangent.